My name is Anderson. Today I'm going to talk about a Linux hat called DinodasRAT. That is actually a cross-platform hat that was found in the last year targeting Windows. This presentation was done with my friend, my co-worker, Fabio Marengi, but he's not actually here right now. So I'm going to present this. Okay, so a little of background before. We need to talk about a research that was made last year by ASET. They named it the Operation Jacana, where basically an APT that happened in the South America, attacking a country called Guyana. And this APT has probably Asian origin, and they was deploying a hat inside the government machines. So the phishing campaign was pretty simple. It was a phishing with the subject of public affairs. And inside, there is a zip file with a compressed file. There is a zip with the malicious executable of DinodasRAT. But this was the Windows version of this hat. After they infect the government network, they will do lateral movement and a lot of other stuff. You can read the research by ASET because it's pretty good. But what caught our attention is because this was happening in a region that I particularly take a look in the South America. So I decided to take a look in the IOCs that was shared. And well, we take a look in the IOCs, that was the C2 of the DinodasRAT for Windows, and they used a C2 domain called update.microsoft-setting.com. So this was like to pretend to be an update server, and by using that, they trying to hide the presence in the network. The thing is that these screenshots are recently, I take a few weeks ago, but at the time there was no detections on these domains and IP address. The thing is that when we look into the IP address, we notice the same pattern, the same idea of pretending to be an update server, but using the CentOS-U. So CentOS is a distribution of Linux based on Red Hat. So this caught our attention because it was looking that they are trying to do the same thing that they did in the Windows, pretending to be an update server. And when you take a look into this domain, we did find an ELF file, an executable linkable format, is a Linux executable, communicating with this file, with this domain. So I decided to take a look into this file. I was not hoping to find the same version of the Windows hat, but ended up finding the same hat, but with a code based for Linux. Writing for Linux. So at last, DinodasRAT for Linux. So, well, it's a hat written in C++. It supported over 25 commands. It has as primary target Red Hat and Ubuntu distributions. It also has a version of multiple versions available. So when we found this version was back in 2023, in October, was the version 10. But after our analysis, we started to hunting a new version. We discovered an early version 7 with debug symbols that was not stripped. So basically, there was a lot of debugging information and RTTI information for the C++ classes. So it has helped our analysis, but a lot has changed between them. So the execution of DinodasRAT for Linux is pretty straightforward. You should first check if it's a Ubuntu or Red Hat machine. If it is Ubuntu, it will verify if it has systemd enabled in the machine. So if it has systemd, it will achieve persistence with a systemd service, and we'll try to verify if the CNC is up. But if it's not as Ubuntu and is a Red Hat, actually, if it's any kind of other kind of Linux distribution, but they try to infect Red Hat, but can infect any Linux, they will use a init script as a persistence, so a system5 using the system5 init system. So after they check if the C2 is up, if the C2 is responding, they will send a heartbeat packet that will basically verify if the C2 is actually responding using the protocol that they expected. If this is happening, they will send a registration packet to the new victim. So each time it will connect to the C2, it will send this registration packet, and it will wait for commands. So these commands are the hat commands. So let's talk about the initialization of this hat. Well, it's very straightforward. It will first verify if the number of the arguments met is different than 3. So why he's doing that? Because If the number of arguments is 0, it means that it's executing directly. So it's the first execution of the DinodasRAT in the machine. So if this is happening in the first execution, it will execute as a daemon. So it executes in the background. Then it will achieve persistence in the machine. I will talk about this in a few slides. And then it will format a command to execute itself in the machine, passing the parent PID as an argument. It will execute using the system function, what we will call the shell with the path of the executable. So it will execute it as a child process, and the parent process we will wait forever until the child exits. So a little closer look at this. So the process will, now in this first picture is the child process already. So the child process will verify if it's running as a root. So it's basically just a check, because this information is useful for execute a couple of commands and to notify the C2 if it already got root. And it will pick the parent PID and save in a global variable. And the parent PID is only used to kill the parent process. So when you're trying to uninstall or stop the execution of the malware. And it's purely a design choice to run as a background. And also, it can be difficult to debug it, but not so difficult. So it's not like an anti-debugging technique, because you can configure debuggers like GDB to follow child process, and you can debug the child. So this is just a malware development design that they did. Okay, so how do you achieve persistence? So as I said before, they support two kinds of init system, systemd and system5. The function that will verify the Linux version by reading a file call in the file call /proc/version. In the proc directory is the directory of Linux that contains a lot of information of the process, is the proc file system. So in Linux, everything is a file, so they can pick a lot of information of the current running machine just by reading these files. So basically, it has like a Linux version number that will verify, and if the number is less or equal to 1, it will execute in the install systemd. But by the code, the only case that will happen is with Ubuntu. So Ubuntu is the target of systemd, and Red Hat-based distros is targeted with system5. So this picture here is the reversed code of the DinodasRAT for Linux version 10. But the version 7, I didn't put a screenshot here, they explicitly has a symbol saying install persistence for Ubuntu or install persistence for Red Hat. Okay, so the persistence with systemd is pretty straightforward. It's just a unit file that is contain some information of the init system. So for those who's not familiarized with systemd, it's basically the first process that will execute in the Linux, and he manages services and other kind of process inside the system. So this unit file will say that this service must run after the network target. So the system needs to have network connection. And it will execute a launcher script that will be placed in the /etc/rec.local. And this register, in order to create a service in Linux with systemd, is pretty simple. You just need to copy a file to the folder /etc systemd system, or just create a symbolic link, as that was the malware do. So that way, it means that every time the computer turns on, it will execute this file, rec.local, after the network connection. And what this file contains is actually a simple code that will call the DinodasRAT using his path and exit. So when we call the DinodasRAT, we'll call the main function, and we'll basically do the same thing to achieve persistence and run as a background. He gets the executable path by reading a symbolic link that is placed in the directory /proc/self/xz that is basically pointing to where the file is in the file system. So that way, every time the computer turns on, it will execute them. But if the system is not using systemd, if not Ubuntu, it will use init script. So basically, we will do the same thing, but we'll place an executable in the folder /etc init.d, and with the name of the executable, so it have the name Dinodas. So basically, this file will give executable permission, and every time the computer will turn on, it will execute it. It has an argument for the file called restart, but this argument is not used because it will do the same process every time. It will run as a daemon, achieve persistence, and execute itself. So it's always trying to pick persistence, even if you already have it. Okay, so one interesting aspect of this version is that it has a configuration, but also has a profile in the same file. So basically, it's a file that will contain information of the current machine and possible configuration that the operator can send to the infected machine. So this profile will have at least one entry that is the victim ID, that is called email. But it also can have other entries that the server can send, like VA, that is a new C2 IP address, that if the C2 is going to be down, the operator can update all the infected machines. The check root key, that is basically saying if the machine has root or not. The proxy address, because the DinodasRAT also supports proxy communication. And also the mode. So this mode key in the configuration is pretty interesting because he can have different values depending on the routine. It's like an argument. So, but in general, it will hold the current bitness of the machine, if 64 bits or 32 bits. Okay, so how DinodasRAT created the victim ID? And it's pretty interesting because it will execute a command inside the machine called DMI decode. And this command for Linux is basically going to dump all the information of the current machine. So basically, what PCI devices are connected, the driver name, the number of processors. So it's a lot of information. It's a verbose output. But this is good to detect what kind of machine is running right now. So it will take a MD5 hash of this output. So now it has a unique identifier for this particular configuration. But this is not enough, because if you are running in the cloud service, you can have the same machine with the same configuration as well. So it will pick the infection date, so the current date that is infecting the machine. It will concatenate this with the previous hash. Then it will generate a random number, and it will concatenate this with the malware version. And you can see here in the printf the format string that it's using, and by using this format string, what we did is to find the new versions of this malware and the old versions, because if you create a YARA signature to go until the V, you can pick all the versions available and in your basis. So it has also an anti-forensics routine that is pretty interesting because it pretends to be an anti-forensics, but it's not. Basically, every time he tries to access some file, it will use the touch command to modify the access date. So in Linux, you can easily find the metadata information file by using the stat command. So if you use the touch command with the parameter -d, you basically can change the access date of this file and the modifying date of this file as well. So it's always changed the access date and the modifier date to a fixed one. This is used every time he tries to pick the path of the executable and when he is writing new configuration. The idea here is to be anti-forensics, but it actually is an artifact to be used in forensics because this date and hour is fixed. So you can use this to hunt in your servers to find new if the server is infected with Dinodas. And in that way, we also can create signatures to find. And we did full sweeping in our database, and we did found some samples that using the same, well, every sample that it has this function has the same dates. So it's not a good anti-forensic. So one thing important to talk about is the network protocol, because when we are analyzing, we try to understand how the communication works, so how the malware send commands and how they send the victim information. And the communication is pretty interesting because he's used UDP and TCP. It can use both, depending the configuration of the operator. The protocol has a custom checksum check, the CRC32, and all the payloads are encrypted with TAA, Tiny Encryption Algorithm, in CBC mode, which is interesting because Tiny Encryption Algorithm it was not built to be used in chained mode like CBC. But turns out that they used code for the message called pidgin. So pidgin is probably some of you guys know, pidgin is a message client that you can use to communicate with IRC, and SHAMP and SMPP, so all these kind of protocols, and they had an implementation of TAA in CBC mode. So what the attackers did was pick the open source code and embed inside the malware to encrypt all the packages, all the network payloads. Well, so here is an example of a network package. So first we have the heartbeat, and then we have the victim registration. The screenshot is basically a C2 server that I wrote, like it's just listen to connections in a specific port, and I patched the DinodasRAT to communicate with this server. So you see that the heartbeat is very tiny. It does not contain much data, but the registration contains a lot of data because it's now sending the encrypted payload with the victim information. So the network packet follows this particular structure. It will have a checksum in the beginning of it, that is a cyberespionage that must match with the entire package after this checksum. And the header will contain a couple of fields, but the important ones are the timestamp, the package type, that is the command type, and the encrypted payload size and the payload itself. So the package type will contain the number of the operation if he's trying to register a new victim, if it is a heartbeat package. And this payload must be encrypted with the client password. So the DinodasRAT has a TAA password inside its code and also has the server key. So all the communications are encrypted before sending the server, and everything that the server sends back is decrypted with the server key. Let's take a look better in the network package. So this is a print screen of the IMHEX X editor. I always use this editor to reconstruct structures before using on other tools like IDA, because it's better to visualize and create projects to edit hexadecimal dumps, so just memory dumps. So basically, I dump the whole package in the disk and open in the IMHEX. So basically, we have the same structure that I talked before. So the first 4 bytes are the SAHISU32 checksum. Then we have the data begin is basically where the whole data of the payload will start. Then we have some, I put some padding because it's not, there is data here that is not so important. Then we have the timestamp, and we have the operation type and the whole encrypted data with the size that is specified in the header. So by picking this pattern here, we could create an emulated C2 that could respond the same way that the node is expected. So in order to respond the package, it must follow the following constraints. So the SAHISU32 checksum must batch with the entire network package, so starting after the header. The timestamp must be the same as requested, because every time he's asking for a command or he sends an output, it will send the current timestamp. If the server the server must return the same timestamp, and this is used to prevent replay attacks, because if you capture some network traffic of the Dinodas on some sandbox or something, if you try to reply it back, it will not be acceptable because it was asked in a different timestamp. So it's a simple check just to avoid analysis, but it's easy to figure out how to bypass it. The payload also must be encrypted with the server key that is specified inside the Dinodas. The server key is available in the paper, so there is the details of the client key and the server key. So the server key will encrypt in TAA, in CBC mode, and reply to the client. So here we have a code that replies the heartbeat, just an example. So it will pick the incoming response from the client. We extract the timestamp because it's an important part, and it will rebuild the same packet, but just with the same timestamp. Then, by the end, you will take this SAHISU32, the checksum, and append in the beginning of the package. So this, in order to convert the same structure, there's a lot of Python libraries. One code that I like to use is this construct, because you can recreate C-like structs in Python. So here we have an example of the network packets of the registration. So here we have a heartbeat. So the C2 receives the heartbeats. It's like a ping. So basically, now it's waiting for the infected machine identification, and then it will send the machine data. So it will contain the checksum, the OS version, the infected machine UID, the EID that they created earlier, the system mode, so it's 64 bits, and the level of the current infected server. And with this server, we can debug and send commands back, because you just need to send the number of the command following the same specification. So you can like execute shell commands and download files and so on. So what kind of commands are available? So it works like a normal hat. So it can list directory list all the files in some directory, delete files, upload files, download files. It can stop services, kill running processes. You can configure remotely, so you can change the C2 address and you will write the new C2 in that configuration file. You can control the services running on the machine. You can also execute shell commands and spawn a new shell, a remote shell, that is not like, it will not be an interactive shell, but will simulate that is like, in fact, executing like a remote shell. And you can change, update the implant to a new version. So you can send a new version of the DinodasRAT, it will kill its processor, and will execute itself. And you can change the configuration, the control type, the connection type, so it can be replaced for UDP or TCP mode very easily. It also supports proxy, so you can change the proxy inside the hat to use some kind of proxy to communicate. By default, it comes without proxy. And also, the communication can be either TCP or UDP, but this is predefined by the author. So the version 10, it uses UDP connection, but the version 7, the early sample, it uses TCP. But this is also easy to change. And it can uninstall itself, that is the function that will call the parent process and will remove itself by the server. So, well, we can conclude that the DinodasRAT is a fairly complex threat, and he's been used by a lot of APT campaigns. So in a recent research published by Trend Micro, it was used by the Earth Karahangan APT group as one of the tools of its arsenal. So if you take a look in the research, it's linked here, you see that the DinodasRAT was using to attack a lot of entities. And when I was investigating this threat, I discovered that we actually did investigation in the past with the TNT5 in 2021, but it was linked with the LuoYu APT group. So basically, you can take a look in the whole presentation, but in the time, the researchers labeled it as XDealer. So it's not like a discovery, but it's like a head discovery of an unknown threat. It was not so popular until you publish about it. And we do have the full research of this published in the security list as well. So it's pretty straightforward, and is that.